Swayam Prabha. Digital India. Educated India.
So, it is a enforcing of certain actually the calculations, certain values that you want to in fact or type expressions that you are writing, that particular consistency is brought by such kind of different kind of language, different kind of type system or different kind of types that are introduced. This is going to be very important when we write even the polymorphism, when we use the polymorphism, because we cannot write, let us take an example here, that I cannot write a in the first two examples you have seen that there is a is elim in, we are saying is element in, okay, is element in, and both T and the array is of type T. But if that particular type does not allow certain operations of comparison, then I cannot use that particular type there. So, I need to put a constraint there. So, that constraint we will talk about that, certain constraints, that introduction of the constraints, that comes actually as a whenever we are defining the appropriate type. So, whenever you are designing anything in O languages also or O way of doing it, or maybe a structured way of doing it, you need to use the appropriate types, and these types are form the basis of appropriate type system. And your all this polymorphism, and why Java introduced it late actually, because it has to be consistent with the existing type system they have. You should not be breaking those things. So, we are talking about this here principles of programming languages, and this particular, so you need to understand that how this particular overall this languages evolve actually. Now, Java actually now current specification is I think 10, okay. So, this whole evolution actually takes in fact requires a lot of understanding that okay, existing type system is this, and if I have to add certain new feature, I need to introduce it in this way. Both the languages C++ and Java are different in terms of treatment of the types, okay, and what basic for the purpose for which they have introduced that certain types, how they can be evolved to define and introduce the polymorphism is important. So, that is why we are talking about all these things here. We need to understand the basic part of the type system as such, okay. You can in fact write nowadays generic program by just doing a Google search, but you need to understand the basics of that now, okay. That is why we are here, okay. Okay, going to the next part, and if you especially if you are writing the type checker of any programming language, you need to understand the minute details of the type system and the type expression, okay. All these languages have evolved to nowadays 600, 800 kind of pages, and their type systems are very complicated. The usage of the particular type and the combination, how you can use it, what happens when this one XYZ is this, etc. It is a very complicated in all this. Even the Java is now becoming has become complicated. Ada and all are too complicated. Okay. Okay. So, now we talked about the this basic few of these first order types, and we talked about this record, union types, variant type. There are other first order types, array type, reference types, then function types, recursive types. Obviously, that recursive types allow you to define this linked list and all this thing, and there is a typical kind of way of defining in different languages. Okay, we will not touch upon that. I will just leave it to you to understand more about it. We talked about this first order type system. Okay. Now, I want to define my there is an integer that is defined in this language, but I want to define a subset of that integer, and I want it to be used exclusively, rather I do not want it to be mixed with something else. So, now we are getting into the first step, that okay, how the new types, definitely we defined the new types using product type, unit type, our own type we defined it, but the thing is that we are now talking about how I can define certain types where I can put certain constraints and the restrictions that these things cannot be mixed with existing type, which is from whom I have derived this type. It's a very interesting statement actually. You can there is a book actually by this guy also, Benjamin Pierce, Types and Programming Languages. If you get hold of that book, do read that. It's a very good book. Type system is a syntactic method of enforcing levels of abstractions in programs. Difficult to understand? Think about it. So it's a very appropriate statement actually, and I always like that in fact. Okay, so how the new types, subtypes and derived types can be defined? In certain languages it is there, because it is important that I define, okay, not all languages allow that. In fact, the type def and all this thing, they are not really allow you to define the new types. It's just the synonymous type actually you are defining with type def and all. There is no, I have not, I don't know about any provision in Java also that I can define certain things as a new type as such. For example, here I can say that integer 1 is in range 1 to 10, integer 2 is in is range 1 to 10. Now I am defining this as a new types actually, okay, and I cannot actually assign A to B. So I will not be allowed to mix. So for example, there you can restrict, let's say, apples and oranges kind of thing. That's those kind of things here basically you are differentiating. Okay. So you have a certain type that you are defined for certain particular purpose. You can use only do the type expressions you can define related to that. You cannot basically mix those two different type expressions here. Okay, that's what it is. Let's go rest of the. I will not get into the details of other thing, but this is a very important, another important part before for us to now evolve, get into the polymorphism. So if you look at the ADA kind of languages, this they used to be called initially the ADA 83 that was introduced. It used to be called as the object based language. Rather than that object oriented, it used to be called as the object based, but because there was no well established object oriented concepts and all these things implemented there. ADA 95 introduced, ADA 95 version, now it's a 2012 actually, but ADA 95 introduced this object oriented concepts in ADA. But there was a very interesting concept which originated from Pascal and Modula and all this thing, and that actually is called as a derived types. So what does it mean? That I have this integer 1, okay, which I defined as a range 1 to 10, and there is a procedure which P, which basically has a parameter integer 1. Now in languages like ADA, you can actually say that you can now define another integer which is new integer 8 to 10, range 8 to 10. Obviously, you are not supposed to break that P's assumption which is range 1 to 10. So, we are defining this 8 to 10 integer, but this is new word is important here. Now, what does it mean? This new means now I do not have to define this P again. Okay, I do not have to do this, define this P again, because automatically this particular type, along with this type, you have inherited this P procedure. Okay, and this is a derived type. This is not an inheritance as such. Okay, this is not an inheritance as such, but this is a derived type which is called as. And you can see that here basically what we here you can call PB, which is perfectly fine, though I have not defined this. This is a comment by the way in ADA. Though I have not defined this, I can still call PB because P is defined for integer 1 and integer 2 is derived from integer 1. Okay. So, this is another thing that this type systems actually, before introducing this polymorphism and object oriented, actually object orientation in languages, this is what was introduced earlier. Okay. And this is important again. Okay, now let us get into the our first topic on the another part of this polymorphism, which is a parametric polymorphism as it is normally called. We will talk about that, and let us get into that now step by step. We will first introduce it to a set in a particular way for the algorithms and all these things, how basically you can write more generic algorithm, more generic functions and the procedures, and then we talk about more about the abstract data types. So let us revisit this. We have seen already this particular thing that I start 50 the type of this particular expression, and type expression basically associated with that. In fact, if I can let us say I combine this particular int and float, I can assign maybe a type variable with certain constraint that okay, it has to be number and all this thing, okay, and it should allow me certain things, right. Let us now define formally what is a type expression. Now let us define formally type expression. Type expression can be in fact int is a type expression, float is a type expression. Type expression, it is basically built up recursively by applying this type operators. Type operators can be the there are different type operators, list, infix operator like a function can be there, okay, there can be multiple kind of things, okay. Two constant types which is a int, but need not be a constant type always, it can be second order also, but yes, right now let us consider that type expression when we are defining here, it is built up recursively by applying type operators to constant types and type variables. Now important part is here is type variable. Let us try to understand this, what does this mean. Let us look at the, let us go bottom up rather than top down, okay. Let us look at the bottom part. Here what we are saying here is that this is a function which takes list of xyz type of elements. I do not know the that particular alpha 1 is a variable. So list of maybe integers, list of maybe a strings, or list of maybe a floating point, whatever it is, list of alpha 1, and this particular function gives me list of booleans, okay, list of booleans. So that is what it is. So now let us consider, let us try to first frame example here. So let us consider we have an array of integers, okay, array of integers. Now this array of integers, from this array of integers I want to in fact evolve array of booleans, okay. I am writing a function which takes the input as array of integers and gives rise to array of boolean, where I also need maybe a something in this case maybe I am restricting alpha 1 to number type, let us say integer, float and double and all this thing, okay, where I will say that particular number, if it is odd then I will replace that by boolean true, if it is a even then I will replace by false. So what I am doing, that function actually takes this particular thing and translates it to list of booleans, but that is one example that I have considered, restricting alpha 1 to number, but what exactly that means that I am doing here, I am considering that I am actually applying certain function to alpha 1 and that function is returning me boolean. So I need apart from, so whenever I am writing list alpha 1 to list boolean, I need a function which operates on alpha 1, okay, which operates on alpha 1 and gives me a boolean, correct, are you getting it. So what was that function, whether it is odd or even. So when it is odd it will return true, when it is even. Now I am, so that function is a one which basically allows me to which actually has to have the property of taking alpha 1 as inputs and then give rise to boolean as a output. So whenever I am writing this particular function here, that list alpha 1 to list bool, okay, what I also require is a alpha 1 to bool as a one particular function again, correct. Now this particular, when I combine this two together, I get a more generic function which actually gives list alpha 1 to list boolean. Is that clear? So this actually is a type expression that we are representing, that I need an algorithm okay, which actually takes there may be a some algorithm that I have written where I have written it for integers only, which takes input as a list of integers and gives rise to list of booleans, but depending on certain predicate, which basically this predicate is nothing but here is that integer to boolean, correct. Now I am just taking it to the next level. I want a generic function which actually accepts a one particular list of that alpha 1 list of alpha 1 and also takes a predicate as a parameter, which actually gives me alpha to boolean. That kind of is a basically a polymorphic function that I am defining. Are you getting it? Any question? So type expression is actually the one which is which actually need to be defined whenever the type variable comes into picture. It becomes a more of a becomes a polymorphic. Okay, whenever there is a type variable that I am defining, simple thing like we do not have to get into the list of alpha 1 to list of boolean. We can say that if alpha 1 to boolean I can define, okay, that itself can be a in fact a polymorphic function. Okay. So let us look at the example here. Okay, now there is a we are saying here list alpha 1 to boolean. Okay, what we are saying here is list alpha 1 to boolean. Okay. Now for simplicity, list is implemented as array and type variable is v, but there is a constraint that is obviously a constraint, or maybe what we can say earlier we mentioned that one predicate is required which will take the input as alpha 1 and then it will say that whether it should be the list, the overall function should return a boolean or not. So that predicate is required, that is mentioned here, predicate here compared to. For example, what we are saying here is that I want to basically to understand, I want to write a function, okay, which is the generic function is sorted. Generic function is sorted. This particular symbol is a function and this is each sorted. Each sorted takes a parameter, this list of alpha 1, correct, element list. It returns a boolean, right. Forget about this part, we will talk about that this part later. Okay. What we are doing here, we are actually using the type system of this v, okay, where it should allow me this compare to, function, and then I can see that, okay, rest of the algorithm you can understand that rest of the implementation, but main thing here is that this is sorted now can be used for integer, for strings, anything. Is it right? Because if only when this v which is a type here, okay, v which is a type here, obviously it should in fact implement certain constraints, then it will allow this is sorted can be used for multiple kinds of types, multiple types. Okay. So this is what we are saying, list alpha 1 to boolean. Okay, list alpha 1 to boolean we are saying here, it is a more, so this is the first polymorphic example where we have introduced v as a type variable. V is a type variable and there is an array of v, and we are taking the, again we are using the v's type system, and the v is basically a function which v allows me to compare to, and then I say that, okay, if it allows me to compare to, then obviously it will this particular function will work. That restriction, that constraints is defined here. Okay, we will talk about that. Different languages provide different ways of constraining this type variables. Okay, we will talk about that. So some of you are familiar with Java, maybe sorry, some of you are not familiar with Java. Are you able to understand this still? I mean, it should be easier. That's it's not a big deal as such, but still I am okay. Okay, now let us consider that particular. So, note this down, later stage I will give you anyway one particular PDF which actually lists down all the exercises that you can do in the next lab session, but just revisiting basically our filter. In fact, in Java and all such things can be done very easily in I think 8 onwards or maybe earlier. Okay, so we talked about this polymorphism, and we just let us look at the one more example of this. Now, here basically we talked, we are again saying that the list alpha 1 to list alpha 1 again. So, that means suppose I just want to pick up odd numbers out of this list array of integers. I want to get an array of integers as an input, and I want to extract basically these odd numbers and prepare array of odd numbers only from this array of integers. Then this is the kind of function which will filter. So, this particular filter kind of function where in a, so this is the functional programming. Okay. So, here basically what we are saying here is that filter of, there is a op here, okay, and that op actually works on only op is one of the parameter for this filter, okay, and op works on only one particular element at a time, okay. And in this case you know about the, how many of you know little about this Lisp or Scheme or any of this language, Haskell, ML, no, you know little, okay, good. So, these are good. So, this is very simple actually, you do not require a deep knowledge at this stage. Here what we are mentioning here, we are representing this filter as a one function, okay, second order function, where it takes the, what has been defined here is that filter whenever there is a nil as a operand, okay, it gives rise to nil only. OP is another parameter which is an operator as a function parameter that is passed. So, and then the second definition of filter is that filter when there is a list that is passed as a parameter which has a head part and a tail part, which has a head part and a tail part. Here head part and the tail part. Head part is a basically you can consider as an array, first element is a head, rest of the array is represented by tail. Okay, that is a very simple way of looking at it. If it is an array of integer, then A0 is head and A1 to till the end of that that is a basically tail. So, this particular operation is that operates on this particular head, and then if that if the value is true, then HD gets added to the output. Okay. So, for example, if the OP is an odd number, see here I have given an example here, that if I call this filter with odd number as a one of the function, okay, which actually picks up which actually operates on each of these elements and tells that whether it is a true or false. So, for example, this particular filter odd number and this list gives rise to this. Is it clear? So, this is now you can see that this all these things actually this evolved for this polymorphism and all actually evolved from this functional languages, in fact languages as such, but it is a very simple thing that here what we are doing here is that we are writing a more generic function, and now it got introduced even in case of Java. Those of you are familiar with I am going to here I have mentioned here that as a part of the exercise you should study the streams in Java. There is a concept of stream in Java, and that stream actually in fact uses these concepts. These are the similar concepts that are actually now incorporated in, and there is also lambda expressions in Java, which is actually a functional programming concept again. Okay. So, this streams in Java, in fact if you use it, you can write one liner or two liner this particular function that that exercise that I have mentioned in the beginning. It is a one liner or two liner kind of expression sorry statement if you use these streams. Okay. So, check that, but you should try to write this particular as an exercise, you should try to write this kind of filter function in Java or C++ and explore this predefined library function filter in Java, especially the I do not know whether C++ standard library has that, but the Java has that filter function, and you can study this particular streams in Java. Now you can see here one important part what we are talking about, we are not just talking about one type variable, but we are composing this polymorphic types here. What we are doing, we are composing here, we are using this particular operator OP, which is basically operating on that alpha 1 to alpha 1, correct. We are using this OP to determine whether alpha 1 actually should be OP is a predicate actually, OP whether alpha 1 should be in fact included in the list, correct. But this is the way we are composing this particular overall polymorphic type. So check the streams in Java, those of you are I do not know about C++ what kind of whether new C++ has this concepts and all, streams concept and all, but check that if it is there, find out more about it, but I know definitely Java has this concept, okay. And it is a very powerful concept, a very powerful kind of streams is a really powerful, and those of you who are using even JavaScript, similar, I do not know whether they call it as a stream, but a similar kind of basically composition, function composition can be done, okay. So output of one to input to another, but the thing is that in Java streams you can have the polymorphic types, polymorphic functions as such, and that actually allows you to combine them in a much better way, okay. Right. So what we have seen till now, we have seen that there is yes, you can express this list of int, list of float as a list of alpha, alpha being a type variable, and type expression we can form where when we do not have any variable, we call it as a monomorphic. I am just coining the name here because you should know that, okay, when it is not polymorphic, it is a monomorphic, that is what we are saying here. So one thing is that if there are no type variables, then there is a monomorphic, and if it is there are type variables, then we have then the type expression is called as polymorphic, okay. So list of alpha below is basically polymorphic, right. Okay, good. So till now it is clear, right. Okay. Now we have to in fact talk more about this particular polymorphism, but before that again there is a, as we talked earlier about this operator overloading, and I also mentioned that okay, int becomes float, okay, there is a coercion that is we mentioned about that, right. All this operator overloading and coercion, they existed, they were there in the programming languages prior to all this polymorphism and got introduced. So this is called as a, so they are in fact called as a ad hoc polymorphism, but they are also a kind of basically a exception that okay, monomorphism does not have a type variable, but the thing is that you allow one star operator to be applied to int and float, both of them. So there is a kind of ad hoc way of saying that I can have a alpha into beta, where alpha is of type number xyz and beta of type number xyz, and still I can apply that star, okay, which will result into, let us say alpha or beta or gamma or whatever it is. So and if required, I will do the appropriate type conversion or maybe a coercion, not only the type conversion, but value also may be changed basically. So this particular is considered there, these are considered as the exceptions to the monomorphic typing rules in fact. So that you still allow this particular overloading kind of operators, overloading of the operators is still allowed there. And so integer constant may have both integer and the real types, right, we have seen that expression earlier, right. So operators such as plus can be applied to both integer and real arguments, that is correct, and that is basically what it is. And wherever the integer value can be used, wherever real is expected, because you are basically defining the type system of that language that requires that type checker to do the coercion, correct. Let's look at briefly about how this type checkers in fact work to some extent. Okay. So definitely, okay, before I talk about that, actually how this type checker works, why this int, whenever we talk about int star float, okay, int star float, why we say that always that int has to be in fact promoted to float or int value is changed to float, why it is required? Because there are no operations in the hardware which will allow mixing of this integer and float also. Okay, it's a definitely, it's a language that defines, but there are no operations within the hardware which allows you to mix, otherwise you have to do it software and it will become too expensive. So if you want to really take the full advantage of the hardware, okay, nowadays even though it is a VM, still it is a hardware which executes, okay, then you should in fact do the coercion, you should in fact change that particular value to the appropriate type so that the hardware can be exploited better, correct, hardware operations can be exploited better. So the coercion is in fact from, it's definitely semantics of the language consistency, but also from the perspective of hardware restriction. Okay, you may not be able to mix, maybe some I do not know, sometimes you are able to do that, but sometimes you are not. 16-bit and 32-bit you cannot add them sometime. So then in that case obviously the language also says that okay, promote this to this and then do that, correct. So whenever we say that okay, this particular type checker, how it works basically for this, whenever we talk about this type expressions and all this thing, monomorphic type overloading and coercion. So if it is a int, then integer, even type is real, and then type 2 is a real, then real. Now here you can see here the third part, else if even type is integer, E2 type is real, implicit conversion and then real. Okay. So the type E types, each type is real. So this kind of rules, okay, this kind of that whenever you are writing a type checker in languages for the language, this is the way that actually person who is writing a compiler, he writes down that okay, this is what it is, because formal semantics of languages actually from that you definitely most of the languages also have some formal semantics, operational semantics defined and all these things, but otherwise he will write down this particular kind of rules and then he will implement those particular type checker, and so this is basically a normal way of writing down, okay, that whether I am considering all the cases or not, okay, before I write the type checker. Now you can see at the bottom that if it is a 3 plus 4.2, then you do a add real, but I need to convert that to real, 3 to real. At the bottom you can see, read that, right, okay, and then add 4.2. Okay, so we talked earlier that algorithms are logically the same. For example, each sorted, we have seen that, right, and that is why I need a polymorphism. I need a polymorphism because I can actually it becomes easier for me, because if I write a one particular that algorithm is applicable, even if you consider some of the other algorithms like quicksort and all, you can still write them if you have been given a comparison operation. If you have been supplied with a comparison operation which works on that elements of that array, then obviously you can write quicksort for most of the other things also, maybe whether it is a string or whether it is a integer, same quicksort. Okay. So now there is a more than that. Let us look at the, now go to the other aspects of this polymorphism, other aspects of polymorphism where we talk about the abstract data types like stacks and all these things, okay, and we get into more about how this particular kind of polymorphism can be useful and the different kinds of polymorphism. We have been talking about the parametric polymorphism restricted to functions, and we talked about this particular ad hoc polymorphism where we talked about this overloading, operator overloading, and we talk about coercion. Now we need to get into more about this parametric, and then also we talk about what we call as the inclusion polymorphism. Okay. So let's look at now, let's get into the object oriented programming, ADT, abstract data types and polymorphism. Okay. So how many programs you have written in C++, those who have written C++ programs, how many programs you have written in C++? Sorry, did I ask wrong question? Yes? Okay. To the Java people, how many Java programs you have written? 10, 50, 100, 1000? Many? Countable or not uncountable? Countable. So you have written many programs. That's a good thing. I am just I don't want definitely good thing that you have written many programs. You have C++ guys, whoever are C++, those guys have also written many C++ programs, right? How many times you have used the concept of a class? Every time. Okay, obviously you have to use that in Java and you have to use that. Okay. But how many times this particular classes were representing the real world abstraction? Okay, name the classes that you have typically written. Sorry? Student. Okay, next. Employee. Next. We will be seeing more actually. I knew that this is a typical examples that you have written it. So I will be talking, in fact one of the exercise will give you the real world mission control kind of alert system as one of the typical classes. Actually we will talk about that as part of the exercise. I have given that because I know that most of these books actually talk about the employee, account and student as a typical kind of classes, but beyond that anyone has used anything? No? Okay, these are the, okay, so fine, I mean definitely that is a good to start with, but you need to associate. Now let us look at this particular, I will take that as an example later. Okay. I will skip this part at this stage, but I will come back maybe later. But let us take a, yes, I am also going to use first as this example, but later I will use a different example. This is a familiar example that you might have gone through, that the student registration system that I have, and this is a typical example that is taken because I want to, let us talk about the simple thing and then we will talk about the more complex things as such. So here actually that you are supposed to develop a new student registration system, and the new system will allow students to register for courses and view report cards. Okay. And then professors will be able to access the system anytime to sign up to teach courses as well as record grades from their mobile or using web. Okay. Then the new system will access course information from the legacy database, but will not update it. At the beginning of each semester, students may request course catalog containing list of course offerings for the semester. Information about each course as a professor, department, prerequisites will be included to make the student make informed decisions. Okay, so last part is that student new system will allow, so there are many things actually. This is a kind of system that you are supposed to develop, let us say. Okay. So there can be many examples. I mean this is a very simple example that most of the time people talk about it, but take an example that you want to develop. Let us take an example that you want to develop a campus security system. Okay. Campus security system, if I have to develop, then in that I can say that okay, campus security system, students should be in fact able, I mean people should be able to understand that okay, whether the entrant is a visitor or he is a one of the staff or the student. Okay. So this you can take, we will talk about this example later, but any of this example there are certain ways of whenever we are designing the software, definitely you want that software to be defined in such a way that new additions to this should be easily made. We should be able to make new additions easily. Okay. The whole idea of abstract data type came actually, and how many of you have done the software engineering course? All of you? Okay. So you have not done it? Done it or not done it? You have not done that. Okay. So fine, not a problem, that is not a big issue. But you are familiar with abstract data type? Are you familiar with abstract data type? All of you are familiar with abstract data type? Okay. So, abstract data type, what are those? How you can define abstract data type? Let me now ask question to you.
Some data type, some methods hidden from real world.
Okay. Hidden, what do you say? Come again.
Is it that some members, some data members or variables which are hidden from real world? You can just give input and get output.
Okay.
You can't get into inside that and look up the code.
Okay. So, generally the example given is the stack is a basically abstract data type where there are operations defined. Okay. Push pop defines that stack. I do not want to know how it is, you can say how it is implemented, right. It is a data type, abstract data type, remember that. Okay. And it is obviously it has certain, it is not a complete object as such still. Okay. It's there is a slight difference between abstract data type and objects, classes as such, but we will talk about that later if we get time. But main thing here is that this particular type of systems, when we are defining, we want it to be extensible, maintainable, we want it to be in fact much more basically easier to, in fact it should be way that if somebody wants to really understand that, he should be able to easily understand that. If I want to change it, I should be able to easily change it. Today I am saying that the certain things are basically we are talking to the legacy database, suppose it is removed and we have our own database, I still should be able to use it easily without changing too much in that particular system. Okay. So, this particular kind of systems, the typical abstractions that you have seen here, why they are called as abstraction? You are abstracting out a behavior that the particular role, particular basically actor that we are talking here is as a student. We are maintaining this particular system, information about that student who is also external entity who is accessing this particular thing. Okay, but the system is not considering this particular student as only as an external person, but also he is considered as a part of this system, because I have to maintain the information about the student, and so I have abstracted out that particular concept or that particular real world object, and which is called as a class here, a student. Okay. So, there may be a so this particular abstraction is a one important part of this particular object orientation. Now, let me just go back again here. Okay. So, earlier languages, there were lots of features that were introduced, like a integer float, monomorphic arrays, monomorphic trees as such. A Lisp actually is it's a Lisp language. In fact, everything is a tree kind of thing actually, car and cadder. Okay. It's obviously you can say head and tail. Okay, you look at that way. Then there were all other things that the product types were introduced, records and Pascal. Lot of programs, as the program started evolving actually, okay, that programming started evolving, and the people started using this particular software getting developed actually for, let us say, for the simple thing like a business kind of transactions, or maybe a mission critical kind of applications, avionics and all this thing. There was a need that was found that okay, this concepts, this particular abstraction, this particular kind of way of constructing the program is good. It's a structured programming approaches are good enough, but the thing is that we require more than that. We require more than that. We require basically we want to represent the real world objects. If I have to do a simulation, let us say, I should be able to represent the real world object, and then I should be able to actually in fact define abstractions for those particular real world objects. Okay. I should be able to in fact incorporate certain generic kind of I need to write some generic algorithms which can be applicable for different types of inputs. Okay. I should be able to write generic the systems which can take certain other systems as a parameters, and they can in fact so for example, let me give you another one of the example here, that we talked about this sorted, each sorted and all, where we said that okay, it can accept a array of a particular type, elements of the array of particular type constrained by certain things basically, but it is applicable for integer, float and all this thing, correct. Now it has to be, we need to go to the next level, saying that I should be able to design a system where I can take a parameter as such as a maybe a particular alert system, which will allow me to send alerts or notifications as I require. But this particular alert system, notification system can be of type XYZ. I do not know about it, but it should provide me these operations. It should provide me these operations. So you have a remote control, correct? I mean this remote control here, correct? This remote control now is connected through my that particular USB dongle, whatever that they have, okay, device that they have provided, and it is connected to my system. That interface actually is the same, okay, maybe implementations may differ, okay. Today this particular implements the implementation in certain way, it allows certain operations like I can highlight, I can change the slide here and there, but some of the pointers may not allow me to change the slides, but the interface remains the same here, correct. So that polymorphism, then the modularity, how to basically divide the system, combine the system, all those aspects they were started asking. In fact in 1968, I will talk more about it when I talk about it in the next lecture, that is at 22nd I am going to talk about that. That 1968 there was a NATO, they had a big software engineering conference, and a lot of things basically were evolved as a part of that particular software engineering conference, okay, 68 and 69 both the years I think, and that actually in fact gave rise to this ADA and all these languages, and all these languages started coming up with how basically this particular complexity can be handled in a much better way in programming. When the program nowadays even the car has thousands or 2000s or 10,000 lines of programs, actually that kind of thing. Earlier it used to be maybe 1000, it evolved into millions of lines of code in avionics kind of software, okay, and that actually is that complexity has to be handled in a proper way. We should be able to package like electronics components, we should be able to prepare the components like mechanical devices, okay. That kind of modularity has to come, that kind of basically interface, if the interface is defined, I should be able to plug and play, that kind of basically software should be able to develop, and that is where all this concept started evolving, and obviously the object oriented languages actually evolved from this, okay. So abstractions, it is easy, I can define it better, I can write the software better if I can abstract out that the certain concepts from the problem statement. There is a problem statement given to me that you have to develop a course registration system, home security system, or maybe a XYZ, okay. We will talk about one more example here, that home security system, forget about a campus security system, maybe home security system, where I should be able to close and open the door automatically, okay. Those, if I have to, then I need to really now abstract out door as one of the concept, door as basically a classification of that particular real world object. I should be able to define in terms of operation that door means that the one which has XYZ dimensions, and it is basically can be opened and closed, the main operations are opened and closed kind of thing. So that abstraction I should be able to define, and this further I need to whenever I design and implement this particular abstractions, I should be able to hide the implementation, I should be able to in fact encapsulate. We already talked about the modularity, I should be able to divide. I have definitely I have classified certain things like student and all this thing etc, but they are part of XYZ system. They may be a part of, let us say, I have also identified, let us say, course catalog, course offering, and these three classes I have abstracted out, but I should be able to modularize to say that these three should become a part of course catalog system. They should not be part of my student management system, course registration system may use this all these three systems to really define the overall functionality, required functionality, but I do not want to mix this thing, I want to keep them separate because I should be able to use this billing system somewhere else. So I need to define certain kind of implementation of billing system, but that billing system should talk to billing system should be usable by the course registration system from the set of operations, and that actual implementation may change. So that is the kind of polymorphism we are talking here, that interface remains the same, implementation changes. Okay. So other specific requirements from real world actually were there can be multiple implementation of the same interface. I want to reduce the redundancy, I want to in fact represent the hierarchy that I find in the real world. So that is basically all these requirements were there. Initially we talk about the real world requirement, that there is an algorithm which is common to I mean it can be applied to integer, float and all, but there were other requirement that this is basically I want to write a complex system, then I should be able to do in a much better way, and I need this, I want to reduce this particular complexity, I want to handle and manage the complexity, I should be able to abstract and represent that particular certain real world objects. All those things actually gave rise to this particular set of object orientation. As our talk is also today about this, more about the design elements of object orientation, object oriented languages. I am just giving a brief about this, that this is the way it evolved basically. Okay. All this basically design elements in object oriented languages evolved because of the real world needs. These real world needs were different for the definitely for the kind of software that you are developing, but yes, they in fact ultimately they somewhere they merged, somewhere they defined more restricted kind of thing, but overall basically this concepts, this particular design elements in object oriented languages evolved from this kind of requirements from the real world. Okay, got it? So where we are? Still we have 10 minutes, right? Okay, we will see one more part. Just brief, we will touch upon this object orientation and all this thing. You may be familiar, I am sure, as you have learned this C++ and Java and all, but we will just touch upon concepts of this object orientation and object oriented, not analysis and design, not technology, but more about related to the programming. So object actually what is object? It is object is an informal representation of entity, which can be physical entity, conceptual entity, software entity. Okay, and object has a state. Okay, object has a state which is and there is a behavior what it can do basically. Okay, we all know about it, right? So this is not a something that, and you do the you classify those objects, and that is where the class concept comes, and that is basically the attributes, operations and relationship. Somewhere it is also called as the messages and all this thing is but we will just keep it to this, that attributes and operations. Relationships, obviously the professor is related to XYZ, and that is why the relationships comes into picture. So it is an abstraction where it emphasizes on the relevant characteristics and suppresses the other characteristics. Okay, and that is what it is important. I am not interested in the professor's height and all these things, so I have not written here. That is basically irrelevant characteristic in this particular context. So we are actually representing the relevant characteristics, remember that. Okay, it is an abstraction, it is not a exact all the details of that professor that we are writing here, right, or student I should, so whatever it is. Okay, remember that, that is a very important thing here, that you are abstracting the relevant characteristics. Okay, you are basically suppressing the others, you are obviously representing that particular professor in terms of its behavior more. Okay, obviously it will have state that whether he is taking this many courses or XYZ courses, that is the state of that professor, but we are only restricting to those aspects of professor which are relevant in this context, correct. Okay, now object oriented programming, what it is, you are using these objects and then your program is represented as a communication between objects. Your program is actually, in fact, when this all this simula and all this, your there were messaging concept were there, okay, there were messaging and all these things. So your program is represented communication between objects. If you really write a true object oriented, if you really design it in an object oriented way, your system, then you can say that, okay, you can really say that, okay, these objects communicate to this object to carry out this XYZ task. But the problem is that many times people actually mix the object oriented way of design and other normal imperative way, and it becomes a more of a procedural implementation many times rather than object oriented implementation, design and implementation. Okay. Okay. So now there is a two things here that are mentioned here, just note it down, subtyping and subjunction. We are going to talk about that, they are very interesting concept, okay, and later we will talk about them. And remember that object oriented programming, the goal is a data abstraction, providing better treatment for many forms, providing better treatment for many forms, okay. That is basically goal of object oriented programming and the code reuse, and the polymorphism becomes important, and the way it goes beyond this type variable or the concept of type variable, how it gets incorporated, that we will see that. I think we will take a break here and then we will come back after 25 minutes or 30 minutes, whatever it is, 25 minutes, keep it to yourself so that you will be here in 30 minutes, okay.